Hello, my name is Kshitij Nikhal and I'm a PhD student at the University of Nebraska-Lincoln. I will be presenting our work HashReID Dynamic Network with Binary Codes for Efficient Person Re-Identification. This work is done in collaboration with the University of Maryland. To describe ReID, consider an input image, referred to as the query image here. The task is to search for that person in that image across a camera network, where the gallery or the database consists of all the person detections and return the top matches for that person. The key idea here is to build a feature representation of the person's appearance so that images of the same identity are closer in the feature space. This capability has been used for tracking missing people, for example, finding a missing child in an airport, or looking for unauthorized people in a secure location. ReID has also been used in law enforcement and intelligence to rapidly build a timeline of a criminal across the camera network. In ReID, we do not know the true identity of the person, so it's considered a soft biometric task for short-term tracking. In this paper, we explore the challenge of efficiently running a model on a compute-constrained device, such as a drone. Our focus is on establishing robust feature representations for the person's appearance, enhancing the matching process speed, and dynamically adjusting computational power based on input complexity or when operating under a limited computational budget. So this work addresses these questions by proposing a hash-based dynamic network. The network generates hash or binary feature representations using the guidance of traditional continuous valued features. This enables to just take the Hamming distance between feature maps for very fast lookup. The network also has dynamic capabilities such as early exit blocks at various stages and can stop computation depending on the difficulty of the input sample or the energy budget, while also generating a shorter feature representation for earlier stages. The network consists of exit blocks at different stages where any backbone network can be used. In this example, we use ResNet 50 with 4 exits at the end of each ResNet stage. The initial exit block consists of additional transformation layers to bridge the semantic level gap between early level features and high level features by utilizing spatial information. We also use the output of the first stage to predict the difficulty of the sample and then choose the exit block accordingly. The difficulty of the sample is determined by training a GRU network that uses training statistics to understand the complexity of the input sample in combination with some heuristics. The binary or hash features are generated by the sign activation during inference and is replaced by the soft sign activation during the training process to make it differentiable. To build dynamic capabilities, we need to determine when samples can exit the network. In this work, we train a gated recurrent network that uses the query and the top 4 gallery matches to predict if the sample is easy, hard, or impossible. We utilize our training process to collect statistics of the number of flips in the top 1 retrieval for the sample at every 10 epochs. At the end of the training phase, if the input flips its decision greater than 3 times, we annotate the sample as hard. For very high number of flips or entropy, we annotate the training sample as impossible or noisy and can exit early to save computation. The GRU coupled with distance heuristics such as the gallery separability distance between 2 matches, which are the top 2 matches of the gallery set, achieves the best performance as seen in the left figure. To optimize the network, we use 3 loss functions. First, we use a triplet loss on representations before the soft sign activation to build discriminability among identities. Second, we use an identity classifier cross-entropy loss to distill information from teacher to student, where the student network, in this case, the binary network, is mimicking the output of the teacher network, which is the continuous valued feature classifier. To ensure similar separability among the continuous and binary valued features, we minimize the correlation between the distance matrix for the top k matches. We test on 3 different datasets, Market 1501, BGC1, and MSMT17. Here we can see some results on the Market dataset where we set a new state-of-the-art dynamic network performance using binary features instead of continuous valued features, denoted by B and C here. The method also achieves better or similar performance using binary features compared with state-of-the-art ReID techniques that use continuous valued features. The bottom table shows the matching time to compare two binary features at different code lengths, and we notice that longer codes have better separability as seen in the mean average precision scores. The figure shows the top one match across various stages for different queries. Easy examples, such as people wearing uniform or distinct clothing patterns, are correctly classified across different stages as seen in row 1. But complex examples, such as identities wearing similar clothing, are predicted incorrectly by the earlier stages and benefit from more computation to get accurate predictions by stage 3 or 4. In conclusion, we propose a hash-based network to speed up the matching process by using binary features for matching. The network has dynamic capabilities to adjust its computation according to the difficulty of the input sample or the computational energy budget. The complexity is determined by using training statistics as training data for the GRU network to make informed decisions about when to exit. The ranking regularization ensures feature similarity between binary and continuous valued features. And finally, by testing the method on multiple datasets, we demonstrate the generalization of the method and set a strong baseline for an efficient network that can be applied to various biometric applications. For more details, please check out our paper and feel free to reach out if you have any questions or comments. Thank you.